Okay, we're going to do a couple more examples with subtraction. We last did part C. Remember that A minus B is the same thing as A intersect B complement. Okay, so you're talking about all the elements in A that are not in B. So A and not B. Okay. Part D is where I want to compute A complement minus C. Okay, so here's A, B, and C. A complement is everything outside of set A, and so that'd be the set containing 1, 2, 9, and 10, I think. Okay, and then minus C. C is just what I've got written there again. Okay, so now remember, when you subtract sets, you're looking at everything in the first set and then getting rid of everything that's in the second set. So 1 is in the first set, 1 is in the second set, I get rid of 1. 2 is in the first set, 2 is in the second set, I get rid of 2. 9 is in the first set, I don't see 9 there, so 9 is going to be kept. 10 is in the first set, 10 is in the second set, I'm getting rid of 10, so 10 is not going to remain. So the only thing that remains there is the set containing 9, okay, which would be the answer. Part E, I get A minus C union B complement. Okay, the A minus C is in parentheses. Now, even if it were not in parentheses, I would still be doing the subtraction first, since I'm reading this from left to right. Okay, it's okay to have parentheses there. There's no harm with that, but I actually don't need them. So A minus C, here's A, and here's C. Okay, so I got A minus C union B complement is everything outside of B. Okay, well here's B, set containing 3, 4, and 7. So B complement would be this set, the set containing 1, 2, 5, 6, 8, 9, and 10. Okay, do what's inside the parentheses first. Okay, so I'm subtracting these sets. Okay, so I got 3. I don't see 3 there, so I'm going to keep 3. I got 4. I don't see 4 there. I'm going to keep 4. I got 5. I don't see 5 that I'm removing, so I'm going to keep 5. I got 6. I don't see 6 that I'm removing, so I'll keep 6. Here's 7 minus 7. Okay, so I get rid of 7. 8 minus 8. Okay, so I get rid of 8 and close up the set. Okay, and then I'm going to union B complement. So I've just written B complement again. And by the way, what I would strongly recommend there is for any one of these problems is to show like a series of steps. Okay, sometimes students want to think about the whole thing all at once and go right to the answer, and I don't know what they're doing, but that makes the problem way more difficult than what it needs to be. Okay, so this is not a problem where you're supposed to think of the whole thing all at once. Okay, that would be very, very difficult. So I would strongly recommend not doing that. Okay, so I'm going to union these two sets together, which means I'm going to join together as one. So the set that I'm going to have is the set containing 1, 2, 3, 4, 5, 6, 8, 9, and 10. Okay. Part F, A minus B minus C. Okay, so I'm subtracting A minus B, so I go ahead and write down A and B and C, okay, which is the sets given to me here. And so A minus B is everything in the first set, but I'm getting rid of everything in the second set. Okay, so 3 is in the first set, I'm getting rid of 3, so 3 is not going to remain. 4, I'm getting rid of 4, so 4 is not going to remain. Here's 5, I don't see 5 in the second set, so I'm going to keep 5. Here's 6, I don't see 6 in the second set, so I'm going to keep 6. Here's 7, I'm getting rid of 7, so 7 is not going to remain there. Here's 8, and I don't see 8, so I'm going to keep 8. Okay, so all that remains there is the set containing 5, 6, and 8. I'm subtracting C, which I've gone ahead and written again. And so what I'll do this again. So keep track of everything that's in the first set and get rid of anything that you also see in the second set. Okay, so 5, no, I don't see 5 in that second set, so I'm going to keep 5. Here's 6. I don't see 6 in the second set, so I'm going to keep 6. Here's 8. I see 8 right there, so 8 is going to be eliminated. And that's going to be the only element in this first set that's eliminated. So the set containing 5 and 6 would be my answer. Okay? Now, so De Morgan's laws are important. So it says that for any sets A and B, where A and B are subsets of the universal set, A intersect B complement is equal to A complement union B complement, and A union B complement is equal to A complement intersect B complement. So all you're going to do is you're going to carry through the complement sign, and then if it's a union sign, or if it's an intersection sign, you're going to flip that to a union sign, and if it's a union sign, you're going to flip that to an intersection sign. Okay, that's all you're doing to have this be true. Problem 34 is where I want to shade the region on the Venn diagram on the left that represents A intersect B complement, okay, and then I'm going to shade the region on the well, let's do that. So okay, so A intersect B, that'd be this part right here, right? Intersect is where I'm talking about both the sets together, and I want the complement of that. So I want everything outside where A and B overlap. Okay, so I've shaded there everything outside of where A and B overlap. And then it says, then shade the region on the Venn diagram on the right that represents A complement union B complement. Okay, this shows the first law of De Morgan's laws, which is true. Okay, so this statement right here. So A complement is everything outside of A. Okay. And B complement is everything outside of B. Okay, so everything outside of B is right there. Okay, now union means that you're going to join together as one. So the question is, where do I have shading? Well, anywhere except for the overlap there in the center. And notice how what I have shaded here is exactly the same thing that I have shaded in the other picture. Okay, so that's a proof showing that De Morgan's first law is true. So A intersect B complement, that's equal to A complement union B complement. Problem 35 says to shade the region on the Venn diagram on the left that represents A union B complement, and then shade the region on the Venn diagram on the right that represents A complement intersect B complement. This shows the second law of De Morgan's laws, which is also true. Okay, so here's the second law. So A union B complement is equal to A complement intersect B complement. Well, union, A union B would be everything in A and B and in the intersection. Complement means everything outside of that. So in this first Venn diagram, I would shade everything that's outside of A union B. Okay, so I've done that. And then shade the region on the Venn diagram that represents A complement intersect B complement. Okay, so intersect means where would you have shaded twice? Okay, so A complement is everything outside of A. Okay, and B complement is everything outside of B. So where would I have shaded twice is the question. Well, it looks like everywhere that is outside of A or B, I would have shaded twice. Since everywhere inside, I only would have shaded one time. Okay, so I've shaded that region darker just to indicate that that region is exactly the same region as what I see over here. So A union B complement, that's equal to A complement intersect B complement. Okay, De Morgan's laws can be handy to use on occasion if you can see them. Problem 36 is where I want us to use the Venn diagram to shade the region representing A intersect C complement union B complement. Shade your final answer the darkest. Okay, so because you're going to have shading like in the picture, it will usually say shade your final answer the darkest, so that you didn't mean to say, oh, well, I wanted this region shaded too, but I just didn't shade that the darkest. Okay, so in general, you're going to want to shade your answer the darkest. Okay, parentheses means that I'm going to start with that first. Okay, so everything in A and C complement. Okay, so everything in A means I've got circle A shaded. Intersect C complement. Okay, so C complement means everything outside of C. Intersection means where would you have shaded twice? Okay, so if I shade everything in A and everything outside of C, where would I have shaded twice? Well, it'd be this region right here. Okay? Now I'm going to union that with B. Union means I'm going to join in more to what I've already got. B means that now I've got some of B already shaded here. Okay, this little sliver of area. I just need to shade in the rest of B. Okay, so let me go ahead and do that. Okay, and anywhere that I have shading there would be my answer. Okay. Let's take a look at problem 37, where it says, use the Venn diagram to shade the region representing A complement intersect B intersect C. Shade your final answer the darkest. Okay, so again, I always start with what's inside the parentheses first. A complement means that I would have shaded everywhere outside of A and B. Okay, the intersect B means where would you have shaded twice? If I shade everywhere outside of A and also B, where would I have shaded twice? Yeah, it's going to be everywhere that I see here, I would have shaded twice. Okay, everywhere that's in B, but not the part where B overlaps A. Okay, and C. Okay, so when I intersect this with C, because I'm intersecting, again, the question is, where would you have shaded twice? Okay, so I've got everywhere in B shaded, not including A, and then I'm going to shade everywhere in C. Where would I have shaded twice? Well, it's going to be this little sliver of area right here, okay, which would be my answer. Okay, if I shade everywhere in C, everywhere in C, I would have only shaded once. Okay, and the question is, where would you have shaded twice? So it's going to be everywhere in this little sliver of area here. Okay, and I've got that answer shaded the darkest. In general, they're going to want that. Okay, just because so somebody would need to know that this little piece of area is not part of the answer. Okay, so the answer is going to be wherever I would have shaded the darkest. Okay, this little sliver of area here. Okay, let's look at problem 38. Use the Venn diagram to shade the region representing A complement intersect B complement union C. Okay, we're going to shade the final answer the darkest. Okay, so A complement intersect B complement. Well, A complement is everywhere outside of A. B complement is everywhere outside of B. Okay, so intersection means where would you have shaded twice? By the way, here's I think a great example of where you would use De Morgan's law. Okay, so if I want to start off by shading A complement intersect B complement, well, here's what that would be. Here's A complement intersect B complement, where I would have shaded twice because of intersection. And so yeah, everywhere that is not in A and B. Okay. union C. Well, so I've got some of C already shaded there. I just need to shade in the rest of C. Okay, so I shade in the rest of C, and I'm done. Okay, so what I see here then, anywhere that I would have shaded would be my answer. Okay. Why don't we stop right there in the notes, and in the next video, hopefully I'll finish up section 2.3. Okay.